Hey folks, Matt Beardsworth here at Bandwidth Audio. We're in the lab, and today I wanted to do a setup video and walk through how to set up and configure our Kaskode One phono preamp. The Kaskode One supports moving magnet and moving coil cartridges. Moving coil is an additional add-on module, so you can upgrade the unit down the road if you desire. And with that comes a whole lot of configurability to get the absolute best from your phono cartridge. So I want to walk through the setup for both moving magnet and moving coil cartridges and how to just get the absolute best out of your phono cartridge, which is really what this product is all about. Before we dive in, we've got some really sweet Bandwidth Audio t-shirts that were designed by a local Austin, Texas artist and musician. We had these available at the Expona show we just got back from, and we've got a few left. So there'll be a link in the description of the video if you want to get your hands on one of these awesome tees showing our brand new 2845 amplifiers. And with that, we'll get right into it. All right, we're over now at the bench with the cover off the phono preamp. So the Kaskode One has some perimeter screws that remove front and back, and the cover just lifts right off of it. Of course, make sure the unit's powered off and you have the power receptacle disconnected from the back before you open up the cover. And then just wait, 30 seconds or so to make sure all the voltages inside dissipate. But once you do that, it's safe to touch. So we're going to talk about the moving magnet capacitive loading first. So moving magnet cartridges, as I'm sure most of you are aware, are loaded in pretty much every scenario by a 47 k ohm input impedance, and the Kaskode One is no different there. The tuning parameter that you do need to dial in for moving magnet cartridges is the input capacitance. And so a moving magnet cartridge, being much higher output than a moving coil, has a lot of turns in the internal coil. Now the coil's fixed, and a magnet is what's attached to the cantilever of a cartridge and vibrates over that coil and generates the voltage. But that coil is physically much bigger and has a much greater number of turns than a typical moving coil type cartridge. And so because of that, the inductance and resistance of that coil makes a filter response that you have to tune. So we're electrically tuning a low-pass filter frequency response by the input capacitance of a phono preamp. And that's exactly what we do with the Kaskode One. So if your input capacitance is too high, you actually get some pretty severe peaking in the high frequency range, and then an artificially low roll-off or early roll-off in the frequency response. And you'll hear that. This can sound pretty harsh in the top end, and then actually not have a lot of air or extension for being seemingly having a lot of high end. And so if that's the case, you probably have too much tuning capacitance. Likewise, if the capacitance is too low, your response will roll off a bit early, and you won't get as flat of both phase and frequency response as you actually can out of a given cartridge. So with an ideal tuning, we get a very flat, near like Butterworth type frequency response, very flat phase, very flat frequency response, well beyond the audible range. And so again, this is just an electrical tuning parameter required to basically tune, again, the filter frequency response that's generated by the motor inductance and resistance that's native within a moving magnet type cartridge. Okay, moving over to the Kaskode One, one quick note about this phono preamp is the native input capacitance of the amplifier stage on the Kaskode One is incredibly low. It's about 15 picofarads. So with that, such a low input capacitance, and as long as you use a low capacitance cable between the input and your phono preamp, you have really great control and tuning ability over your cartridge. And so that's done with these two switches up here. We have switch S5 and switch S2 over here to tune your input capacitance for moving magnet mode. So right now on pin S2, or switch S2, there's switch positions 1, 2, 3, and 4. Switch position 1 is in the on Notice how the silk screen on the board says on, capacitive loading. That gives us 200 picofarads. The layout in the Kaskode One is actually mirrored, so left and right sides are mirrored in order to create a low noise, sort of balanced dual mono topology. So for that reason, this switch position is also mirrored. So pin 1 is now down here, and it is in the on position, so we've got 200 picofarads active. If we wanted to, say, enable 300 picofarads, we can enable these in any combination. So if I take a small flat blade screwdriver and flip that switch up, we now have 100 on and 200 on for a combined total of 300 picofarads. And that's it. It's that simple to tune the capacitance in. And I'll make a note. Having it on the board like this makes the input wiring loop around the input of the amplifying stage really small. Keep in mind, phono preamps have massive amounts of gain for a linear analog system. Probably the highest gain signal chain, analog signal chain in an audio realm that I can think of. You rarely see anything else that has, in electrical engineering world, that has analog gains as high as phono preamps. And so for that reason, this input stage, any noise that's picked up in the wiring here will just get amplified downstream and all the way through to your output. So that's one reason why we actually put the tuning right on the board and don't have external switches. It helps us achieve that excellent performance. On top of that, once you set this up for your cartridge, you're not really tuning this. You're never touching this. So this scheme, once you set it up, you put the cover back on and you don't have to touch this for years. So we made the decision to implement it this way rather than having knobs and extra cost and switches and everything on the front fully accessible, because you shouldn't be messing with that anyway. And if you are, something's wrong. Something's wrong with the tuning or the ability for that phono preamp to work with your cartridge. With this setup here, we can tune in any cartridge, zero it in, you button the cover, and you don't have to touch it again. So as I mentioned, our user manual shows you the switch positions, those capacitive loading options, and then of course every combination that's offered. So you can get a really precise dialed in tuning capacitance and really, like I said, get the most out of your moving magnet cartridge. And of course we show an example. This shows the switch positions correct for 150 picofarads. And then also in the user manual, as we just showed in real time, we show you those switch positions for the tuning. And that's it for moving magnet. Okay, so for moving coil input tuning, it's a little bit different, and actually the physics are quite a bit different in what you're doing. In the Kaskode One phono preamp, for moving coil mode, we use a step-up transformer, and then the tuning is done with a variable tuning resistor in parallel with the native 47 kilo ohm input impedance of the phono preamp stages. For moving coil cartridge, the tuning is not in contrast to a moving magnet cartridge where you have an electrical filter that you're tuning due to the cartridge's internal inductance and resistance. For moving coil, what you're actually doing is mechanically damping the needle with this tuning resistor. So that needle's vibrating, and the internal resistance of a moving coil cartridge, it's got a coil that's only a handful of turns to make it really light, and that's what's sitting on the cantilever moving around, right? That's what moving coil means. That low resistance coil needs to be damped in order to control the motion and damping factor of the needle. It's like output impedance of an amplifier, except we're trying to find the optimal impedance in order to control the needle. Just like output impedance of a speaker, the lower the output impedance, the better control of the cone or the woofer of excursion. With cartridges, arbitrarily low is actually not the objective. There's a range that you're trying to get in terms of the input impedance of the phono stage in order to critically damp the needle movement and get the best performance. Hopefully that makes some level of sense. But getting into it, there's basically two tuning parameters. there's that tuning resistance and the input transformer ratio that's adjustable in the Kaskode One. So the Kaskode One supports 1:5, 1:10, and 1:20 step-up ratios. All of those are natively available with that moving coil add-on module. And so with that, in each step-up ratio, you get a range of different loading resistances for your cartridge depending on the loading switch position. So basically you pick your step-up ratio, and then once you pick your step-up ratio for your cartridge, you select the correct parallel tuning resistance to get the correct loading resistance. Hopefully that makes sense, but basically that switch that controls the resistive tuning is controlling this resistor, and because of the different step-up ratios, you actually get a different reflected impedance on the input side that the moving coil cartridge sees. So that's why we can't list a number, we have to list a range. There's 3 different loading resistances based on the tuning resistor that you switch in, and so we show that here. So for example, in a 1:20 mode with the switch in this position, which gives you a loading resistance of 15 kiloohms, the impedance that the cartridge sees is 39 ohms. That's how you use this table. And I'll show an example using our online calculator in a second. So that's the tuning resistance. The other parameter you need to tune is the step-up ratio. And so that step-up ratio, as I said, 1:5, 1:10, or 1:20 is controlled on our moving coil step-up boards. And so those switch positions are shown here. So if I move over to the Kaskode One, here's our moving coil module. These switches are set up in a 1:10 configuration per the data sheet here. So we set up both the left and the right side in 1:10, and that sets our step-up ratio. That job is done. The final step, as I mentioned, is to then tune your input impedance switches to set the correct input impedance. So for example, as I mentioned, I guess in this case we're in 1:10. So if we're in 1:10 mode and say we had a 10 kiloohm tuning resistor, we're about 100 ohms of loading on the cartridge, which is a very common range. And those switches are shown here. So you again, these are mirrored. So switch position 1 is up here, and switch position 1 on this one is down here. And you can see the silkscreen says on and off. So as long as you flip this per the manual, and you've got the correct step-up ratio, you can use this chart to figure out exactly what your loading is based on your step-up ratio and your loading resistance range. That's how that works. It takes a second to kind of think about, but once you know how to just use this table, it's really quick and easy. And again, the flexibility of this preamp is pretty amazing, giving you all of those options. And we really can tune in any cartridge, and we've not had a customer yet who's not been able to get amazing results with whatever Phono cartridge they choose. So with that, I wanted to run through now one quick example. So on our website, we actually have a calculator tool. Let me move these papers. We've got a calculator tool that shows you the best ratio to set this up. So for example, I went online and just pulled the specs off in Ortofon Cadenza Black. So from the data chart off the cartridge, there's 2 specs we need: output voltage and internal impedance, or DC resistance. Those are synonymous for moving coil. So 0.3 millivolts, which is 300 microvolts, and 5 ohms are the output specs of the cartridge. That's all you need to determine the optimal loading. So what we do is you actually, in our calculator tool, and again, you can download this from bandwidthaudio.com, you put in your cartridge resistance, you put in that output voltage, 300 microvolts or 0.3 millivolts, and then what the calculator tool does is it gives you some values. So what it actually calculates is your ideal cartridge SNR, and then the SNR, signal to noise ratio, through the step-up module. And what you're looking for is the least amount of signal to noise ratio loss. And so as soon as you put in those numbers, these boxes turn green, and it's suggesting that you should be using a 1:20 step-up ratio with that cartridge. It also shows you the output voltage after all of the step-up is done, and we're at 4.74 millivolts, and that's the actual output voltage at the output of this transformer after all the loading is taken into account. This is a pretty complicated network, and so we do all the math to figure out, based on the resistance of the windings of the transformer, the loading, and the reflected impedance, and your cartridge. We take all that into account with the calculator to give you the best step-up ratio. So 1:20 is suggested. Once you understand where you think the loading should be, then you can fine-tune by adding in your secondary loading resistor. So in this case, we've got 10 kilo ohms, 10,000 ohms, and that gives us a reflected impedance of 27 ohms. So in a 1:20 step-up ratio, in this example, we'd be loading the cartridge with 27 ohms. If we go back to the data chart, it has a recommended load impedance of greater than 10 ohms. So 27 ohms is obviously greater than 10 ohms. That's probably a great place to start. And you can give it a listen, and then what you can do is, if it's sounding really dull, you probably have too little load impedance. So instead of 10K, you can jump up to the 15K, which would give you 39 ohms of loading. And so again, once your step-up ratio's set at 1:20, you can adjust this switch. Just move up one position or down one position on these resistive loading switches to fine-tune the cartridge loading to taste. And that tuning is really to taste. Like I said, if the cartridge sounds dull and doesn't have a lot of transient response, it sounds just kind of lackluster, your cartridge loading is probably too low. You can go up a step and see how you like it. And then you can go up a step again and see if it becomes too bright and lively. Then you can kind of zero in really quickly on your happy spot. But using this calculator tool gets you pretty much right where you need to be every time. I've got one more example. This is a VPI Shyla. So in this cartridge, output voltage is 0.6 millivolts, resistance is 12 ohms. So 12 ohms, 6 millivolts. Notice this is twice the output voltage of that previous cartridge. So not surprising, this is suggesting a 1:10 step-up ratio. The SNR is really good, and your output voltage from the final loading and that transformer is 5.3 millivolts, which is in a nice happy range for the Kaskode One. And so that box turns green when you put those values in. The Shyla recommends a minimum impedance of 100 ohms. Perfect. If we pick a secondary loading tuning resistor of 15K, we're at 158 ohms. Great starting point, and as I mentioned, you can then go up to the next one or down one, and you've got quite a bit of tunable range in there to dial in the sound for that recommended cartridge. And again, in our user manual, we show you exactly how to do that and what the switch positions are. So not rocket science, just takes a second to think through, but once you have it and understand what you're trying to achieve, the tuning on the Kaskode One's actually really easy. It's really straightforward. Our customers have been really happy with the flexibility. We've had a number of customers running numbers of different cartridges, throughout years of ownership, and have never found an instance where they couldn't get absolutely awesome sound out of the cartridge, which is the entire goal. So I hope you enjoyed this video. Please like, comment, subscribe, and if you've got questions, feel free to reach out to us at bandwidthaudio.com. Thanks for watching.